Good morning, everyone, and welcome. My name is Amund. I am the convener of CEN TC156 Working Group 26. Eurovent has asked me to come and introduce the EPD topic for you today and to tell you a little bit about the work ongoing in Working Group 26. And that is what I intend to do. But before we begin, a quick raise of hands. For how many of you is the EPD topic completely new? If I raise my hand, it's strict. That's not a good sign. But okay, so you're a bit familiar with it already. That is good. Then you know there is a lot of 3 and 4 letter abbreviations in this stuff. And then you are well prepared. I work in Systemair, by the way, and we have quite a large stand here at ICE. So if anyone would like to have a more in-depth discussion later on about this topic, feel free to come and visit us. So I'll be here today, tomorrow, and Thursday, before lunch at least. For manufacturers, the EPD topic is about adopting a life cycle approach towards their products. And a life cycle approach requires the systematic mapping and assessment of the environmental and resource impact during the life cycle of the products. The typical setting is the products being used in some type of building. The life cycle includes the making of the products, the installation of the products during construction, the use of the products during the lifespan of the building, the disassembly and disposal of the product at end of life of the building, and finally, benefits and loss after end of life, including the recycling and reuse potential of the product. The question is, how do one do such a mapping and assessment? And how do you document it? And this is where EPDs come into the picture. So what are EPDs? An EPD, or Environmental Product Declaration, is a document intended to describe the environmental impact of a product or a service. EPDs are based on life cycle assessments of the products. They are combinable. All EPDs are given on a standardized format, which enables easy aggregation of data on a top level. They are sometimes said to be comparable. However, this is only true under very, very strict circumstances. They are approved by a third party, and they are notoriously costly and time-consuming to make for the manufacturers. Within the construction industry, EPDs have been around for many years already, but they have been mostly limited to what you would call ordinary construction materials. For the last few years, however, we have seen these demands develop to include technical equipment as well. When it comes to the use of EPDs, first of all, they provide environmental consultants with the necessary information they need to perform life cycle assessments for buildings. Secondly, they can provide building owners with a better basis for assessing the impact of a product or a service. And finally, EPDs can provide manufacturers with environmental information for use in product development. Originating from construction projects, mostly in Europe, but also elsewhere sometimes, these requests for EPDs propagate down the construction work supply chain. The reason behind the requests often gets lost on the way down. But behind these requests, we find the fact that these life cycle assessments for buildings are becoming mandatory. First via local building codes, but soon via EU directives. When it comes to building life cycle assessments, it is important to note that these EPDs are not the only source of information. In fact, detailed energy calculations of the buildings are key parts of these building assessments. In EPD terms, the ventilation products industry is a small part of a much larger construction products industry. And as mentioned, and as this figure shows, these EPDs have been around for many years already. And the numbers are increasing exponentially year over year. All EPDs must be issued via so-called EPD program operators, the list of which you can see in the bottom of this slide. This segmented program operator structure represents a large and potentially costly problem for the ventilation industry. The big challenge we face is the increasing emergence of diverging national EPD requirements, resulting in several sets of EPDs per individual product with different declared environmental impact in each one. This is an undesirable situation, not only from manufacturer's perspective, who has to make all of these documents, but also from an EPD user's perspective. And this is why the Working Group 26 initiative was proposed, approved, and finally started in January of last year, with the goal of putting in place a widely adopted European CPCR standard prescribing how EPDs for ventilation components should be made, and perhaps also how they should be used and not used. In the end, enabling one EPD per product valid across Europe. So here's another one of these abbreviations for you, CPCR. CPCR stands for Complementary Product Categories. And complementary refers to EN 15804, which we need to adhere to fully. In this standard, we find the core rules for all construction products. And we are in essence making complementary, non-conflicting rules for ventilation components. The hierarchy will look something like this, with our standard sitting on top of EN 15804. Below EN 15804, we find another important standard called EN 15978. This standard prescribes how life cycle assessments for buildings must be conducted in Europe, really providing the all-important context in which these documents are intended to be used. Below, we find the requirements for life cycle assessments for buildings, as mentioned, already implemented in some local building codes, and soon mandated via EU directives, namely the Energy Performance of Buildings Directive. EN 15804 provides a pretty good standardized definition of an EPD. And it states, an EPD communicates verifiable, accurate, non-misleading environmental information for products and their applications, thereby supporting scientifically based fair choices and stimulating the potential for market-driven continuous environmental improvement. This is about optimization, of course. And you cannot optimize based on faulty information or misleading information, presumptions. The information must be accurate and non-misleading for this optimization to work. And our task in Working Group 26 is to achieve this not in a Swedish setting or a German setting or a French setting, but indeed in a European-wide context. In our work, we are aiming for a broad consensus. We are indeed dependent on this to get our standard published. To help us reach a consensus, we have defined some overarching goals. The idea being that if we are able to agree on what we would like to achieve with the standard, it would be easier to reach a consensus on its content. And the 4 overarching goals we have are as follows. First of all, we are aiming for a set of rules that delivers from what is being demanded from us in the market, fully in line with the basic context and framework already in place for these EPDs. Secondly, we are aiming for a set of rules that actually ends up promoting better sustainability, because this is not a given. Thirdly, we are aiming for a set of rules that enables digital workflows. And last but not least, and perhaps more important than ever now, we are aiming for a set of rules that enables the cost-efficient creation and updating of these documents. When it comes to specific product groups, this standard would be applied to all products covered by Technical Committee 156. In essence, ventilation systems and components for buildings are subject to human occupancy. A notable exception is air filters, which are being dealt with in TC 195 in a working group led by Tobias here, which you will hear from shortly. For all of these other products, we need to come up with a principled and coherent framework. This is indeed one of the main tasks and also main challenges in the standardization process. Avoiding so-called branch-specific deviations between the parts. What we come up with must be principled, coherent for all of the products on the list. Despite some differences, of course, there are also some really important common denominators for these products. As standalone components, most of them provide little or no value. But when you combine them into ventilation systems, they become critical. Critical for achieving healthy and good indoor environments, critical for achieving energy efficient buildings, and indeed also critical for achieving a more sustainable construction sector, which is all this stuff is about. The challenge we have is that the interesting stuff happens when you combine all of these parts, and we are creating rules for the components themselves. So one of the big challenges we have that we must succeed with is to maintain this overview. Because what really is interesting takes place when you combine these parts into systems. Thank you.